Today I'm going to be walking you through the 4 most common causes of high head pressure on the Trane CVHE and CVHF chillers. I'm going to be starting at number 4 and working my way towards the most common issues on these machines. So take notes as we go and good luck with your troubleshooting. Some symptoms of high head pressure on these machines would include obviously a high head pressure fault. Chiller could be surging really bad. The chiller may not want to load up due to the condenser pressure limit. You guys might get that on the screen. Essentially, all that's doing is it takes the high pressure cutout and it factors 93% of that, and it keeps the machine unloaded to prevent it from tripping on high head. So the first thing you got to do is make sure everything's calibrated. So go through and get some ice water, calibrate all your sensors in ice water, and they should be within 2 degrees of 32 degrees, obviously. So plus or minus 2 degrees. If the unit has transducers, make sure all those are calibrated as well. Make sure they're within a PSI of your gauge that you're using to calibrate it with. And then after that, go ahead and fill out a diagnostic sheet on the machine as well so you can follow along and help you with your diagnosing. Issue number 4, the chiller could be overloaded. So I've had issues with this in the past where the inlet guide vane assembly is not working properly. Maybe the linkage is jacked up or something's bound up inside there, or the little pin is sheared or something stupid. So that'd be the first thing I would probably look into because it's pretty easy to test. The next thing obviously could be a high evaporator load. So if you're running a 80 degree entering chill water temp on the evaporator, you're obviously going to be running a very high load, and so the condenser is also going to be running a very high load. So you might have a load limit in the compressor that will prevent it from loading up any further. So you may need to go through all the settings in the controller and make sure that everything's configured properly. You could have an issue with your cooling tower. Maybe it's not sending cold enough condenser water back to the machine. So if the condenser water temp entering the machine is very high, you're also going to have very high head pressure because of that. And it's also going to overload the machine. I do have some other videos that break down diagnosing a overloaded machine. So if you guys think that this is the problem, go check those out and they should be able to help you out a lot more. Issue number 3, fouled tubes. So this can be caused by a bunch of different things. The most common thing that I see that is caused by, honestly, is improper water treatment. So a lot of times chemical companies want to send them tons of chemical, or they want to send them some fancy piece of equipment, but it's not set up properly. It's not feeding enough chemical, or it's not reading the water properly. And so they end up having issues with the machine fouling up really bad. So the picture on the left there is a machine that's extremely fouled. When you pull a end bell off, it should look similar to the machine on the right. Granted, you're definitely going to have some debris and stuff that builds up in there over the cooling season, but it should not be fouled up to that extent. So in the spring or in the wintertime when they're punching the tubes on the thing, you really should only have to punch tubes on the thing once a year unless it's a really strange condition. If it's a specific application where they are running really nasty water through it all the time and they can't prevent it, maybe they need to punch the tubes more than once a year, but it should only really need to be done once a year. So chemical treatment's probably the number one thing. Another thing could be obviously lack of maintenance. So if they're not punching the tubes regularly, they should be doing it once a year. If they're not punching the tubes, that's definitely going to cause the problem as well. Some other things I've seen, missing or rotten screens for the loop strainer. So if the strainer's not picking up all the crap that comes through it, all of it's going right into the condenser. And since the condenser is the lowest velocity, everything's going to drop out right in the condenser. And you'll be able to tell from your diagnostic sheet. So I do have more videos on this as well, breaking down, diagnosing, and cleaning up the fouled tube. So if you think that's it, go ahead and check those out, and hopefully they'll get you on the right track. Issue number 2, poor condenser water flow. This can be a result of dirty screens on the condenser piping. If you can see on the right there, that's supposed to be a screen for a suction diffuser on a pump, and it is completely full of rust chips. This can be caused by a bunch of different things. So one of the things I would say, the first place you should be looking is going to be the screens in the system. So pull all the screens, check all the screens, make sure none of them are fouled up. The next thing you can check is all the tower nozzles. Make sure the tower nozzles and the headers are all clear. Make sure there's no rust chips in there. Make sure there's no gunk in there. And then sometimes rust chips or cooling tower media or things like that might get lodged in the entering side of the condenser, so that can get fouled up as well, but you shouldn't be checking that till the very end. So check your tower nozzles, check your screens, make sure everything's clean. If that stuff's clean and you still think you have a condenser water flow problem, then go ahead and pull the piping side of the condenser and go ahead and check that out. See if there's any rust buildup in there or any debris that got lodged in there that could be blocking the flow. I'll have some more videos coming out as well on diagnosing condenser flow, but this should get you started. It's pretty self-explanatory. Most of the time it's got a plug screen. Most of the time it's plug nozzles or something like that. Those are the most common things I've seen. Issue number 1. Air in the refrigerant. On these machines specifically, they're running in a vacuum, so it's really likely that you're going to get air that accumulates in the system over time, just operating. And if the thing's sitting for a long time, you're also going to get air accumulation in the system. So that's why it has this purge unit. The purge unit pulls all the air out of the system and rejects it after it goes through its purge cycle. It's not super common that you have a lot of issues with the purge units, but it does happen. Typically, air will get in the system via leaks, and since the system's in a negative pressure all the time, it's sucking air in instead of pushing gas out. If you want to check and see if there's air in the system, it's pretty simple. Just shut everything down, run both your pumps, and then check your pressure temperature on your pressure temperature chart. So you should have a 0 degree approach if there's no air in the system. If there's air in the system, you might have a couple degrees approach, a couple PSI difference between what it should be and what you're actually reading. If you think you have air in the system and you need to get it out to get the machine online, connect a recovery cylinder to the top of the condenser and go ahead and vent it off the top of the condenser into the recovery drum. Do it in a few second bursts, 5-10 seconds. Vent a little bit of gas off the top into your drum, and then check it while it's operating and see if that made a difference, how the change took, if it seems like it's improved the problem, if it changed anything, if it didn't change anything. But it's pretty easy to actually test that. If you're not in a hurry, you can just turn your purge on all night, turn the alarm settings up in there and just run it overnight and see what it does the next day if you want to try to do that too. But it's really easy just to vent off the top into a drum. So that's usually what I do, just to get the thing online so the customer can get their machine operating again. So if you did end up having air in the system, then you need to look into why you got it in there in the first place. So you'll more than likely need to leak check this, and to do that you're going to need to pressurize the system and then leak check it. Like I said before, it may be worth looking into the purge system as well. So if you do have leaks in the system and it seems like they're not very substantial, if they're really small leaks, then you're going to need to look into seeing what's going on with the purge unit as well. You're pretty much always going to have some leaks just because the system's in a vacuum all the time. I also have more videos breaking down how to diagnose the purge system, and I'm going to be coming up with some more videos here in the future, just how to diagnose your purge system, how to leak check everything, how to pressurize the system, things like that. So hopefully it'll help you guys with diagnosing.